Hi. G- Good afternoon, good evening for most of you. It's morning for us here in New York. My name's Ash, and this is Anna, and we're going to cover how we can build an AI stylist using IBM Granite and watsonx.ai. Anna, do you want to move over to the next slide?
Sure. Let's go ahead and introduce ourselves. Ash, if you want to go first.
Sure. So I'm a technical content manager here in New York, working for IBM.com. And we're responsible for building out technical content that goes on our website and on our public-facing channels. And so we're very, very lucky that we get to play with the latest AI technologies that IBM has to offer and produce compelling things like this AI stylist. Anna, over to you.
Hi, everyone. I'm an AI engineer and developer advocate for IBM.com. So my job is to make technical content for developers to consume, mostly AI related, as well as building out internal tools to help optimize and automize a lot of the manual processes on our team. So super excited to be here today and show you guys our latest project. So I'd like to start off our workshop today with a personal anecdote. A few weeks ago, I found myself kind of falling into the habit of wasting half of my morning routine, which I consider precious time, staring at my closet, thinking, what should I wear today? I don't even know where to start with picking items from my closet. And so, after some time, and as my annoyance snowballed, I finally realized, why don't I save some time and use AI as a personal stylist? And so, this is exactly the reason why we built Styli. Do you care to share with everyone a bit more about our app, Ash?
Sure, Anna. So we released a new vision model a few months ago, and when we were thinking about what we could do with vision, we decided to write some prompts and do a little bit of prompt engineering to see how the model would handle input of various sorts, and as well as being able to use those inputs in ways that could add value to developers. And one thing that we realized was we were getting really, really good categorization out of our vision model. And so when we thought about that, we thought if we put together a data structure of what we look at with the vision model, maybe we could make some sort of structure that would allow us to actually create a closet object of some kind. We then just, I don't know, we got carried away, right, Anna? And we thought, okay, cool. So what could we do with this next? And then we decided to build a little Streamlit application, which is what we see in front of us on the screen here, which allows you to sort of like interact both with our vision model as well as our reasoning model. So in summary, what you're looking at right now on the screen is a little Streamlit proof of concept application that we built that allows you to upload images, and using those uploads of those images, we'll create a data structure out of those images based upon the vision model inferencing them, and then we'll then pass that structured output to another model where you can then say, hey, I'm going somewhere and I need a formal dress code, and I'm going on a certain time of day, and I'm going in a particular season. And both the combination of the reasoning model as well as the structured output that we can manage to get from our vision model gives us a really good output for what your outfit could be. And Anna's running through our demo right now for you all to watch. So as you can see, she just picked a few images. We sent that off to our vision model. She then put a bunch of parameters in for where we're going to be headed and the time of day and what the season is, as well as like a free text form of I'm going to go in the park. So we've got a closet of images on one side. We're going for a casual afternoon in the spring in the park. And now the combination of those two things are being passed over to watsonx, and we're creating that data structure from all the images that Anna passed in, and then passing that over to do some reasoning. Anna, I don't know whilst this is going on if we should show people behind the scenes what's being generated by the vision model, like the actual JSON output.
Yeah, I think these things kind of take a little bit of time for both the vision model to analyze each image and then for the instruct model to provide its reasoning. So we can definitely share as we go the output that we're seeing on the back end. But for now, I think we can move along and continue with the presentation, and then I'll just kind of jump in as we see the results populate, if that works.
That sounds great, Anna. Let's do that.
Awesome.
Okay. So here's a bunch of sample images that we've provided in our GitHub repo and what we've used. You could pretend that this is my closet. Okay. And we're going to show you a little architectural overview of how these pieces work in the next slide. So Anna, if you move over to the next slide, as you can see, so what we were doing in our Streamlit application is we're providing a bunch of image files and some user input, and that's going to our vision model first of all, and we're creating this JSON structure where we're inferencing against the model, and we're saying, provide us this information in this structure based upon the images that we're providing you. We're then taking that structure of our closet as well as the images, and those go to then our reasoning model, where the reasoning model is then doing the thinking, as it were, to actually put together the outfit. So the vision model is basically creating our data structure with our closet of items, and our reasoning model is using that information to then put the outfit together. And hopefully this little slide showing you some sort of architectural view helps to explain what's going on behind the covers. Anna, do you want to move over to the next slide?
Sure. Yeah. And before we move on, I just want to add, I think it's awesome to see the two kind of Granite models working together. I think you usually see, one model kind of behind the scenes of an application. But this is like making the most out of both models, and I think it's just a really great application that is also very relatable and usable by many of us. So yeah, let's move along.
So if you scan this QR code, this should take you to our GitHub where we have the source code for this demo. That short link also will take you to the exact same place. We've provided both to you here, just so that you can get started. I tested this before we got onto the live stream, so hopefully this works for everyone. If you have any issues, feel free to post a message in the chat, and we'll try to respond to that. But yeah, without further ado, Anna, shall we get going?
Yeah, let's do it. So hopefully by now everyone has scanned or entered this URL. Let's give it a few more seconds. So now we'll be jumping into the hands-on aspect of the workshop, and then we're actually going to build this app. And so our first step is to open our preferred IDE. So in my case, that would be Visual Studio Code. And we'll see here the project structure. So our project is takes in several kind of files. First, we have watsonx.py, which will kind of handle all of the calling of the API. And then images.py, which will parse the images and provide the image descriptions. And then finally, AI stylist.py is kind of like the powerhouse behind this app, where you will see most of the Streamlit logic, as well as some other helpful functions. So once you have this kind of general structure of images.py and watsonx.py being in the source directory, we can go ahead and get started. So I'll start off with watsonx.py. So first step, like usual, we're importing any kind of relevant packages that we may need. And we're also loading in our credentials from our .env file. And so we have an example here of how your env file should look like. This should have your watsonx API key, your project ID, and your the URL endpoint. So that's location specific. And if you need some help finding these credentials or generating them in the first place, if you check out our tutorial that we just linked to in the previous slide, you will see instructions there on how to generate those credentials. So moving back on here, you'll also see we're overriding them. So if at any point your credentials expire and you update your .env file, that will ensure that we are overriding any outdated credentials. So our next step is to create a generate outfit function. So this function takes in several parameters. It takes in the image descriptions that are generated by the Granite vision model. It also takes in a bunch of user input. So we have the occasion, the location, the time of day, as well as the season. We then instantiate our credentials. So we have, again, the URL, the API key, which then allows us to create an API client and pass in those credentials. We also are here, we're just stating our model ID that we'll be using. So this is the Granite 3.2 AP instruct model. And then we're also providing our project ID from our env file. This allows us to instantiate a model inference. And so we just call this reasoning model just to kind of differentiate from the other vision model. And so here we provide our model ID, our API client, as well as our project ID. Next, you can see this is our most important prompt. It tells the model to use the description, category, and occasion of the clothes in our closet to put together an outfit for a blank occasion at this time of day, at this location. And the event takes place in this season. So that, again, is taking in the user input and filling in those missing variables. We're also making sure to return only one shirt, one pair of bottoms, and shoes so that we're not seeing, outfits that we wouldn't actually be able to wear. We're also telling the model to use the description, category, and occasion provided, and to not classify the items itself. So by this, we mean we don't want the reasoning model to kind of override any of the image classification that the vision model has already done at this point. And so in that way, we're ensuring that our output is consistent. We're also telling the model to include the file name of each image in the output along with the file extension. And we're then we're providing our image descriptions. And so the file name is important because, as you'll see later on, in our Streamlit app, we provide the ability to then also display the image of each corresponding clothing item that the model recommends for our outfit. And so in that way, if we tell the model to provide the file name, we can then extract the file name and display those images. So we'll get more into that as we go, but just kind of want to give a little bit of a heads up there as to why we're telling the model these specific things in our prompt. Next, we can structure our message input. So here you can see we are telling the model to enhance its reasoning. This is the way that we can inform the Granite 3.2 instruct model specifically that we want it to provide that enhanced reasoning that it's capable of. We're also passing in the prompt. And finally, we're putting this all together and chatting with this reasoning model by providing our messages and then extracting from that output the string content and returning them. Okay, great. So now that we have watsonx.py set up, we can move on over to images.py. And just like before, we are importing any relevant packages for this file, as well as loading in our credentials and overriding any outdated ones if that applies. Next, we can create a function to encode our images. So as you can imagine, the model needs to be provided with these images in a way that is parsable And so the way to do that is to base 64 encode them. So as you can see, we're passing in the images as the parameter. We're then iterating over the images. And as we go, we're base 64 encoding them and appending them to our loaded images list and then returning that list. So you'll see this function being called in the other functions that you will soon see. Next, we have our augment API request body function. So this one takes in the user query as well as an image and allows us to, instead of, obviously, we don't want to hard code every request that we're going to send to the API. Instead, this allows us to have that flexibility of just calling a function and passing in a new image each time. And so you'll see here, this is for the vision model. So we're not doing anything with reasoning here. We're simply just providing the user query and then the image as well. And we're informing the model that it is base 64 encoded. Okay, great.
And we're doing that because we're going through each image one by one, right, Anna?
Exactly. Yeah, we're not kind of dumping all these images at once. We're calling the API at each step. So, yep, thank you. Okay. So the next really important function in this file is the describe images function. So this one actually calls the vision model to categorize and describe each clothing item. First, we create a list called closet. And we then instantiate our model inference of the Granite vision model. We also provide our credentials, so URL, API key, project ID, as well as any parameters. So we set our max tokens here to 400. We found that to be an ideal kind of sweet spot for the length of the output that we're looking for. So we don't want super elaborate descriptions of each clothing item, but we also don't want just kind of 5-word responses either. So this is an ideal, I think, token limit. We're also setting our temperature to 0. So this kind of tells the model to not be too creative and to kind of just stick to the most probable output. Here we have our user query for the vision model. And so in this prompt, we're telling the model to provide a description, category, and occasion for each individual clothing item. So again, we're only passing in one at a time. We're also telling the model to classify the category as either a shirt, pants, or shoes, and to classify the occasion as casual or formal. So as you saw earlier, when we told the model that we have a casual event to go to, we want to make sure that the vision model is able to determine, well, which of these items are casual, right? So this is our way of doing that. Next, we're telling the model to output valid JSON and to not create any new categories or occasions. So again, trying to limit any kind of hallucinations and to only use the allowed classifications. And then we kind of provide a skeleton structure of what the JSON schema should look like. So for each image, it should be the description, the category, and finally the occasion. And so our last portion of this function iterates over the list of images and then augments the API request with this user query above here, as well as that specific image that we are, that place in the list that we're at that point. And then we're chatting with the model by providing our message input and extracting the string content of the response, printing that. This gets printed just on the back end, so you can kind of see where the model, at what point it's at within the list of images. And then we're finally appending that image description to the list that we created up here called closet, and we're returning that list as the final step. Alrighty. So now that we have images.py set up, we have watsonx.py set up, we can now move on to AI stylist.py.
Okay, so in essence, our AI stylist.py is our Streamlit application. So a lot of the code that you're going to see here is us importing libraries from Streamlit, as well as creating parts of the UI. All of the actual inferencing work against watsonx and using the Granite models are in those two files that Anna's just described.
Yes, exactly. Alrighty, so AI stylist.py. So as we just did, we're going to import any relevant packages. So in this case, we'll see Streamlit here, since all of our Streamlit code will be in this one file. And we're also importing those specific functions that we built out in those other files. So you can see the describe images, base64, load images, and generate outfit are all imported here. Okay, so now we can move on to kind of the bulk load of the Streamlit code. And so a lot of this is just kind of the setup of the app. So basic configurations like the page title, the icon, which we have in here as well. You can also find this in our GitHub repository so that your code doesn't generate any errors. It'll take in that icon. You'll also see that we're setting the just kind of other page configurations here, just to kind of get the visual appeal of the app going. And so we also set our title, styli, and then a project description. So where AI meets fashion design. And of course, we're powered by IBM Granite. We're also displaying that icon. And so the first kind of markdown that you'll see apart from the app description is prompting the user to tell us like what's in their closet. So first thing that you'll see is a file uploader where like you saw earlier, you're able to access any local files that are either PNG or JPEG format and upload them. And you can upload a bulk load of images at a time. You don't have to upload them one by one. Next, we ask the user, where are you headed? So they have the option of choosing either casual or formal. As you'll see, this is a segment and control component. So it only limits the user to those two, and they can only pick one or the other, as you most likely would never choose both at the same time. Next, we provide different times of day. So we have morning, afternoon, evening, and this is also segment and control. So only one of these can be chosen at a time. Next, we ask the user to select a season. So winter, spring, summer, fall. Again, only picking one of these at a time. And finally, we have a text input. So this is completely up to the user to type in where they're headed. This can be a coffee shop, it can be the office, or it can be, somewhere on vacation. So this allows for a lot of flexibility here. And also keep in mind, just because we kind of have these options available, that doesn't mean that these are the only options that you can work with. You can adjust the prompt as you desire. You can include more functionality, more options. You can essentially just complicate this as much as your heart desires. So a lot of flexibility here to get the app that you are dreaming of. So next, we have our start stylist function. This one is called whenever the user presses the generate outfit button. So we have a spinner that just kind of shows out the process has begun, that the models are doing their job. And the first thing that we do is call the base64 load images function, and we're passing in those uploaded files. Once we have those images encoded, we then pass those encoded images in that list to the described images function, which calls the vision model and provides the image descriptions. Once we have those image descriptions, we can then enumerate them. And as we go, we can parse the JSON output and convert it into a Python dictionary, which we're doing in this step here. We're then extracting the file name from that output. And we're also just kind of converting all of this into JSON string as well. So these are just kind of formatting steps here. And then next, we're calling the generate outfit function. So this one takes in those image descriptions, the Streamlit kind of input here, so the occasion, location, time of day, as well as the season. And then once we have that final outfit, we can tell the user that we're done. But before that, we're also loading all of these image descriptions in a list called closet and returning both the outfit as well as that list closet. Okay. Next, we can create the check valid input function. So this one essentially is there to check whether the user is missing any vital input that would prevent the model from successfully running. So the required input, like we talked about, is the occasion, location, time of day, and season. And if any of these are missing, which would make this missing variable list greater than 0, right? If there's one thing missing, it'll be 1. If there's 2, then it'll have a length of 2. And if that's the case, then we return an error message that indicates exactly which input is missing. Okay, and then our kind of final set of Streamlit code here, we have the generate outfit button. And so once that's pressed, and once we have checked that all of the input is valid, nothing is missing, we can then start the stylist. And so if at any point we have an error generating the outfit, maybe the model isn't running, maybe for some other reason, maybe we've changed the code and now things just aren't working, we'll let the user know that there's an error. And a fun additional feature that we added in our app is not only are you going to see your outfit that the model is recommending, as well as the displayed images, but you're also going to see a table consisting of all of the contents of your closet. So you can then kind of see which items the vision model classified as casual or formal, and if they're like a pair of pants or a shirt. So you can also kind of cross-verify. In that way, we're keeping the human in the loop by ensuring that, the model is correctly classifying each individual item. We've seen great results, but I think it's helpful to just see your entire closet as well. And so if we do have an outfit, we're able to show the selected items header up here, and we can iterate over the uploaded files and extract the file names as well. So like I mentioned, the way that we can display the images is by extracting those file names. And we can also go ahead and display that table. So this wraps up our code for this project. So if you were to run this app, you would first need to set up a virtual environment So I can just do Command-Shift-P and click here, Python, create environment, create virtual environment in the current workspace. And my preferred Python version that I've just been comfortable with is Python 3.11.9. And we can also just select the requirements.txt file so that we can install those dependencies while we're at it as well. So I'll just head over here so you get a better visual understanding of what we have in here. So we have Streamlit, we have any kind of image packages needed, LangChain, IBM watsonx packages, libraries, and yeah, so our virtual environment is being created. Okay, great. It says we are in our virtual environment, but just to verify, we can open up our terminal. And you'll see here, we are in that virtual environment. And so now to create, to run the actual app, you'll need to run this command. So streamlit run AI stylist.py. Let me move on over to this window. Bear with me. Okay. So this command started our app. And so you'll see here, it's everything we just talked about. We have our the name of our app, the icon, the kind of hook, as well as all of the Streamlit input options as well. So, and also earlier we talked about getting back to that output that we generated earlier. So I can also show you guys what that looks like on the back end before we kind of start this demo. Or actually, maybe we'll just do this first and then in parallel go through that. So in my images directory, I have a bunch of images of clothing items to pass into this app. So those are shirts, pants, shoes, pretty much anything in your closet. We recommend not including images of more than one clothing item at a time, just to not confuse the model. I found it best to include one clothing image in each, one clothing item in each image at a time. Next, we can select where we're headed. So it's a beautiful day today in New York. Let's say we're headed for a casual afternoon in the springtime, since it is spring, and we're headed to the park. So we'll click generate outfit. And while that's running, I can show you here what the output looked like on the back end from the previous demo that we just ran earlier in this presentation. So as you'll see, we were able to iterate over those images, and for each image, the vision model provides a description. So let's take this one just as an example. A pair of tan leather boots with a chunky sole and a high top design, suitable for casual wear. So that's great. The model not only was able to tell us what kind of an item this is, it's a pair of shoes, it's also able to pick up on the design, the color, the chunky sole, and it also is able to tell us that it's for casual wear. And the category, like expected, is shoes, occasion, like expected, is casual. So you see this for all of these different images. You don't see the output here because that is on the front end of the app. But so let's see. It looks like this is taking some time to run. But okay, here, great. So you'll see here, we provided the images. We can see that the process is completed, it's done. and we can see the thought process of the model. So the occasion is a casual afternoon at the park in the springtime. I need to select one shirt, one bottom, and one pair of shoes that fits this casual spring appropriate theme. And I'll ignore items that are not suitable for this input. So it knows to not include formal pants or winter materials. So that's great. That's great to see. And so here is the model response. For a casual afternoon at the park in spring, I recommend the following outfit. So for the shirt, we have a plain white t-shirt. We also have the file name. So that's great, as we'll be able to display these images at the bottom of the page. The model determines that this white t-shirt is a versatile choice for a casual afternoon. It's lightweight, breathable, and pairs well with both pant options. And so this is the combined effort of the vision model and the reasoning model. The vision model describes these images. The reasoning model then is able to provide enhanced reasoning for which items go well together for the specific occasion. Next, for the bottoms, we see a pair of black pants with a zippered pocket on the right side, and we also see the file name. And so the reasoning model states that the black pants offer a sleek and stylish look suitable for a casual yet put together appearance, and they're not too formal and can be easily dressed down with the chosen footwear. So let's see what the footwear is exactly. It's a pair of black suede sneakers. So this is the outfit. I think that's really cool to see that the model knows that, maybe these pants could be considered formal, but if you pair them with casual sneakers, it's no longer formal, it's casual. So that's great. We also have the file name, and let's just see the last final output here. These blue suede sneakers are perfect for a spring day at the park. The color is cheerful and complements the white t-shirt without being too loud or overwhelming. Suede also gives a nice spring touch to the outfit. This outfit is casual yet well coordinated, ideal for an afternoon spent enjoying the park in the spring season. Okay, this is awesome. This is pretty thorough. This is not overwhelmingly thorough either. So it's great to see the kind of succinct responses that we have here. And as we talked about, these are the contents of your closet. So every single item that you uploaded, we can see the description, we can see the categorization, the occasion, and the file name. So you can always kind of cross-verify these things. And you can even download this, maybe use it for a different purpose. And then, yeah, we have our final image output. So this is the outfit for a casual spring afternoon in the park.
Anna, thank you for walking through that. Okay. What are some of the ideas that we've had since we've been through this? I think one of the things that I was thinking was, could I get this to work with an agentic workflow where I could just generate my outfits for the whole week, and I just get an automated email or message or something that says, hey, I've been through your closet and I've looked at the weather and here's the outfits for the next 7 days for you. I mean, I know that's one thing that I was thinking of moving on to next as taking the code from this project. What ideas did you have?
Yeah, that's a really good one. I was thinking of providing maybe some kind of location-based reasoning. So instead of having to put in maybe your occasion and the season and all that, if it knows where you're located, it can determine what season it is already, and maybe even use a weather tool, like you said, in an agentic approach to get the weather and to provide that output super specific to your location. I think that would be a really cool additional touch. There's definitely lots to configure and personalize.
And if you go back to the source code for a few moments, Anna, when we made this, I guess one of the reasons why we designed this the way it is if you go to images.py, for example, that prompt right there that's on line 49, we're just creating a data structure from what a vision model can see, right? So you could make that be the contents of your refrigerator, right? And be like, hey, classify these food items and give me back a data, a structure of data for, is this dairy? Is this like vegetable? Is this like, right? And so people could reuse this code and in lots of various use cases outside of a fashion stylist, right? I mean, if we changed the prompts here, we probably could see how far we could get with doing that. Or even more importantly than that, I mean, there's probably a lot of business use cases here, right? Like, let's just say that the vision model, instead of classifying sort of clothing or food items, it could be classifying types of documents and then be categorizing those documents where people have a lot of like scanned information that they need to process in bulk, right? And again, if we went to the watsonx.py function, watsonx.py file, right? That function that's in there with the prompt that's on line 25, we're just interpolating variables that we're passing into this, right? And we're talking about occasions and times of day and so forth. That could be anything really. It could be whether it's the food example that I gave earlier, describe a kind of like meal for like breakfast, lunch, or dinner, or even more serious use cases than that. We could kind of go, is this a complaint? Is this customer like, is this like a happy email that we're getting from a customer? Like, there's so many ways that you could take this code, right?
Yeah, I think anyone in the audience that's interested in actually running this code and kind of adapting it to their use case, it's not a business use case, but they will see that we have a project already in our repository in notebook format that takes the same code and instead kind of alters the prompt, alters the input, and is able to provide personal training advice. So
yeah.
yeah, you'll see that we were able to upload images of our gym equipment and have the model provide us with customized workout plans for our specific kind of target workout. So if it's cardio, you'll see a more cardio-based workout plan, our strength training. We also, I think, configured the duration of the workout. So that was a fun kind of other use case that we thought of, but I definitely think there are a lot of enterprise applications as well. So if anyone has any fun running this app and kind of creating their own use cases, please reach out to us. I think that'd be super fun to hear about.
Yeah, we'd love to hear that. Okay, Anna, do you want to jump back to our slides?
Yeah, let's do it.
Okay. So we built an AI system. It provides style-specific advice, okay, based upon your user's needs, right? We're using pictures of clothing to make outfits that are customized to meet the specified criteria. And we use the Granite Vision 3.2 model for doing this to basically inspect and categorize each item. And then we used our instruct model and leveraged its thinking abilities to generate those personalized outfit ideas. Yeah, that was kind of what we've been through today with you all on this dev day. And there's a bunch of stuff that you could do. We've already touched on already. Like, you could customize this some more. You don't have to use Streamlit. You could chain these functions together in a separate way and maybe create an agentic workflow. Put more item types in, integrate it with e-commerce, integrate it with a virtual try-on experience. There's so many things that you could do with this.
Yeah, exactly. So just to build off of the e-commerce idea, like, let's say you have some clothing items that you're interested in purchasing, but you're struggling to envision the final outfit. Maybe you're going on vacation and you really want to have a great outfit. You can put in those images of those clothing items and then pair that with an e-commerce tool. There's plenty of pre-built tools, or you can build your own. And then maybe you can get product recommendations. So if a pair of pants goes really well with some top on that same store, or maybe from a different store, that e-commerce tool could then recommend you those other items. So definitely, again, lots to customize and build upon here.
You know, one thing I thought of, Anna, when we were building this, which I didn't mention already, is for me personally, it's like if I'm going to go shopping at a clothes store, I'm kind of like thinking, is that going to match with what I've already got at home? Right.
Exactly.
And that would be super cool, right? Like if we could use this and kind of like say, hey, I'm thinking of buying this item. What outfits could I make with the stuff that I already have with this new piece of clothing, right? And this would be a perfect use case for what we've built here too, right?
Yeah, exactly.
Okay, so we have a tutorial on our website which walks through everything that you've seen here today, so you can follow along. We're also providing you a QR code scan here to our GitHub, which will give you access to not only the code that Anna's walked you through today that we've shown you in VS Code, but we also have a Jupyter notebook, so you can run through it cell by cell and follow along and see what's going on. And yeah, here's our URLs for our LinkedIn profiles. So feel free to connect with us and on LinkedIn, and we'd love to know if you build stuff with this and what you build with it, and happy to answer any more questions.
Yeah, thank you all so much for joining our workshop. We hope you are able to use our source code to create your own application or just be able to run hours and use it in the day-to-day. This was really great opportunity. So we're super grateful to be able to talk to you all today and share our latest project.
So Anna, we have a question from the audience, and I'm just itching to answer it, but I'm actually going to ask you, and then hopefully you can answer it, and then I'll maybe also will respond, okay? So a question we've got from the audience is, could the model also predict based on fashion styles, e.g., what kind of shirt goes with baggy jeans?
Yes, so absolutely. I think the way that we have the prompt set up for the reasoning model allows exactly for something like this. So if you were to, include an additional line in the prompt that says, tell me based on this blank fashion style, the appropriate outfit, it'll be able to do that for you. So if you're looking for maybe loose fitting, you mentioned baggy jeans, so maybe like a loose fitting, comfortable outfit, you can definitely include that and build out the front end feature for that as well using some pre-built Streamlit component, another maybe text input, kind of how you see at the bottom of the app. And by doing that, you would definitely be able to get the model to predict based on fashion style. Is there anything you wanted to add to that, Ash?
Yeah. So if we go back through our slides to our sort of architectural overview, Anna,
Yeah.
right? When I look at this and I think with this sort of a systems thinking approach, there's two ways that we could do this, right? The first one is provide the pictures of the baggy jeans to the vision model and let the vision model do its own categorization of what those kind of jeans are, right? So it could be as simple as just provide the images and let the vision model handle it. And then also there's the other aspect which you suggested, Anna, which was that we can provide an extra piece of information that goes into the prompt for the reasoning model, okay, where you are providing in a sort of like fashion style to kind of go, I want baggy jeans in my outfit. So you're kind of like providing the reasoning model with a bit of direction in terms of what style you're looking for. So right now we have the occasion, the time of day, the season, and the location. We could probably have a fifth thing there, which goes sort of like, what kind of style do we want, right?
Exactly.
Maybe we should tinker around with that when we get a few minutes and see. Have you got any baggy jeans?
I don't have any, not on me, but it's definitely something you can test out, and I'd be happy to hear about how that goes. But I do think, like you said, with the first option, I think the model most likely would be able to kind of determine like whether baggy jeans would be appropriate for high heels or not. Like I think it'd be able to, with the reasoning model, determine the appropriate sneakers and shirt. But definitely a great question. So thank you for asking.
Yeah, and I don't see any other questions right now, Anna. So I think that we may be done with our session. Maybe you should just go back to our slide with our QR code on and our contact details.
Yes, let's do that. So you'll see our IBM.com tutorial here. We kind of have this in notebook format, as Ash mentioned earlier. So if you are maybe not too familiar with Streamlit and you rather just kind of run this in a Python notebook and see how it works step by step, that is also an option. You'll find both versions in our GitHub repository.
Okay, and we would love to see what you build. So if you do build things, find us on LinkedIn, mention us, show us what you've put together. We would love to see.
Yes, look forward to connecting with many of you. Thank you all.
Thank you.